Welcome back. Today our target are the equilateral triangles. There are two learning targets, so please copy down on your classwork book. Number 1. I can apply the property of equilateral triangles to find the unknowns in the triangles. Number 2. I can prove for an equilateral triangles. So be careful. Number 1 is finding the unknown, but number 2 is about the proof. And then there is a reason property of equilateral triangle we need to apply today. So let's have a quick review of an equilateral triangles. So an equilateral triangle is a triangle with three equal sizes. Also, it also has all the properties of an isosceles triangle as well. So we may apply the reason of the isosceles triangle to deduce the property of the equilateral triangles. So let's consider this figure. It is an equilateral triangle ABC. If we look at AB and AC, they are equal sizes. Then we can deduce that angle B equals to angle C using the base angle isosceles triangle. If we take a look of the equal sizes AC and BC, then we can also deduce that angle B is equals to angle A using the base angle isosceles triangle. Then we combine these two facts. Then we can say that angle A equals to angle B equals to angle C. And furthermore, we have the angle sum of triangle, which is 180 degrees. Then therefore, each of them should be equal. And then they are 60 degrees. So this is our property of an equilateral triangle. For any equilateral triangles, each interior angle is equals to 60 degrees. And then this is our reason, property of equilateral triangle. So let's look at the example. In the figure, this is an equilateral triangle, DEF. Can you find the value of x for me? Since this is an equilateral triangle, we may apply the property of equilateral triangle to say that each of the interior angle is 60 degrees. Therefore, by solving the equations, we have x equals to 20 degrees. Now, a second example. In the figure, triangle DEF is an equilateral triangle. EFG is a straight line. If the angle FDG is 18 degrees, find x. So once again, since I have given you an equilateral triangle, then you may apply the property of equilateral triangle to say that angle DFE is 60 degrees. And then we look at the triangle DFG. We can apply the exterior angle of triangle to say that 18 degrees plus x equals to 60 degrees, which is the exterior angle of the triangle DFG. So by solving the equation, x will be 42 degrees. So let's move to our second part to prove a triangle is an equilateral triangle. If we know the three angles of the triangles are equal, that means they are 60 degrees. Then the triangle is an equilateral triangle. So now, let's look at this figure. Is triangle ABC an equilateral triangle? Now we have got the angle A and angle B, but we don't know the angle C, so we need to find out the angle C. Using the angle sum of triangle, we may find out that angle C is 60 degrees. So now, since all of them are 60 degrees, then we can say that AB equals to BC equals to AC. Then therefore, this is an equilateral triangle. So here's the last example. In the figure, AE and BD intercept at C. Angle BAC equals to angle DCE equals to A. If CE equals to DE and AB is parallel to DE, determine whether the triangle CDE is an equilateral triangle. CDE, that means the triangle at the bottom. So let's start. First of all, since AB is parallel to DE, then we can apply the alternate angles. Do you still remember about the alternate angle? Just like the English letter Z. Okay, so the angles in between the two parallel lines are equal. So that means this one and this one are equal. So we look at the triangle CDE. Since there are two equal sizes, CE and DE are equal, so we may apply the base angle isosceles triangle to say that the base angle, angle C and angle D are equal. Then we can conclude that since CDE equals to angle CED equals to angle DCE equals to A, then we can conclude that CD is equals to DE equals to CE. And then, therefore, the triangle CDE is an equilateral triangle. So now it's time for the practice.